So, hi everyone. So, last class we had studied acid, bases, and salts chapter, and today we are going to continue with the part 2 of this session. Okay. So, part 2 of the session, I am going to teach the topics which is going to be covered are how do you measure a strong acid or base. Okay. Then we are going to study about salts. Okay, in salts we have different types. Okay, that is neutral salts, acidic salts, and basic salts. And we have to study different types of salt formations. Okay, then we are going to study about this is the continuation of this topic only, that is pH in everyday life. Okay, so this is what the topics we are going to cover. It will hardly take around 30 minutes or something so, and we will in detail we'll study about this. Here these topics are very important, okay, because most of the questions in acid bases will be asked from here. Okay, so let us start with the session. Okay, so the first topic is how do we come to know that the given solution is a strong acid or strong base. Okay, for this we use something called as a universal indicator. Okay, indicator. Okay, what do we use? We use something called as a universal indicator. Now what do you mean by universal indicator? It is an indicator which is made up of several indicators combined together, and which on different concentration of H plus ions will give different color. Depending upon this color, we will tell whether the given acid is strong or weak. Okay, remember the strongest one will be always red. Okay, and as you go down the color will change, and the strongest base will be blue. Okay, dark blue or something like that. Okay, so this is depending upon the color we can tell whether the given solution is a strong acid, weak acid, or strong base or weak base. Okay, now the measuring a scale is used here. Okay, a scale which measures, okay, these concentrations, we call it as a pH scale. Okay, what do you mean by pH? P stands for potence or potential of hydrogen, which is a German word, and H is a hydrogen. Potence of hydrogen, we call it as a pH. So this pH scale is there, no? That is also where an universal indicator colors are indulged in the scale. Okay, and that we call it as a pH scale, which basically means it measures the concentration of H plus ions in a given solution, and that we call it as a pH scale. Okay, so remember, now we will understand the pH indicator. Okay, that is 7, 0, 14. Okay, 7 here is considered as a neutral. Okay, such as your water and those things all are neutral. 0 is the strongest acid. Not possible. And strongest base. Okay, the concentration of H plus ion increases. The concentration of H plus ion increases towards from 7 to 0. Okay, so that means as you go up the group, up the number, the concentration of acid increases. That means the stronger the acid. as you go from 7 to 14, that is the OH minus ion increases, indicating that as you go down the group, that is as you go down the number, that is 7 to 14, the basic strength increases, the OH minus ion increases, that means the strength of the base increases. Okay, so this is how we will measure whether the given solution is acid or basis. Okay, now coming to the next topic. Okay, so remember, this will be red in color. If you see in universal indicator, this will be in red in color. Okay, as you go 1 2 3 4 5 6, the color will change, and 7 will have a green in color. Okay, 7 means if it is neutral, it will be green. If it is strong acid, it will be red, and if it is 14, it will be dark blue color, dark purple or dark blue color. Okay, understanding? So this is how we represent, and this is how you remember the pH scale. Okay, now coming to the next topic, pH used in our day-to-day life. Okay, first of all, what is the importance of pH in the day-to-day life? Okay, we know that all animals and plants or any organism require some amount of acid and bases in their life to survive. Okay, for example, aquatic plants. Okay, do you think plants will survive under acidic conditions? Okay, or animals will survive with in aquatic? What I'm trying to say here is every animal has a range of pH in which they can survive. For example, plants and animals has a range of 7 to 7.8. Okay, 7 to 7.8. At this range, animals, this is a pH range where animals bound to survive. Okay, then all living organisms can survive under this range of a pH. Now what if it is reduced? Okay, that is if it becomes 5.5. How can it become 5.5? Now for example, aquatic animals. Okay, so they live in a pH range of 7 to 7.8. Now because of some reason acid rain happened. Okay, and the pH of the water is changed to 5.8. Do you think animals will survive? No. Okay, so this is how we will understand there is a range to all the living organism. At that range the animals will grow faster, or they will grow or survive or something. Okay, if that is reduced due to some environmental or external factors, it can lead to the dissurvival of the organisms. Okay, that is what I was trying to say. Okay, so if it is less than 5.8 or 5.6, that means it is a acid rain. Okay, now how is acid rain caused? This we have studied in 8th standard and all. That is the pollutions which is released by, okay, the pollutions which is released by, that is sulfur dioxide and nitrogen dioxide or trioxide, which is released due to vehicles or any harmful pollutants or any factories, that will go and combine with the water which is present in the atmosphere, and this will lead to an acid rain, and this will give something called as a H2SO4 and HNO3, which in return leads to the acid rain, and with this can change the pH range of aquatic animals. Okay, then we are going to study about next in this. Okay, that is backyard. In your backyard, the soil of the pH. You might have heard that I have told in the first class, there are certain flowers which will indicate whether the given soil is acidic or basic depending upon the color which they give. Okay, same thing. If in your backyard there is a soil, okay, so soil has a specific pH range at which it can survive. Now if for some reason if the pH of the soil is changed to 5.2 or 4, what will you do? Okay, so if that is the case, you have to, for this if this happens, that if the pH of the soil is changed, if it is changed, you have to neutralize this. How do you neutralize this? By adding base to it. If it is acidic, if the pH is acidic, you will add base to it. If the soil is basic, you will add acid to it. What are you doing here? You are just neutralizing. Okay, so if the soil is acidic in nature, you will add something called as gypsum, okay, which is nothing but a base itself. Okay, gypsum ka formula is a CaSO4 2H2O. Okay, that is a calcium sulfate dihydrate. Okay, calcium sulfate dihydrate. Now next thing in this is our digestive system. Okay, our digestive system. Okay, so what is the pH range of our what do we have in our digestive system? Our digestive system has something called as an acid, that is a strong acid which is present in our stomach, which is protected by a mucus. Okay, and this acid ka pH range is 1 to 3. Okay, so if an acid level is increased in your body because of the food which you have consumed, what will you do? Okay, for this we will take something called as antacid. What is an antacid? An antacid is something which will reduce the level of the acid in your stomach. Okay, so now antacid. So I told that you just need to remember a neutralization reaction in your mind. Okay, how do you neutralize? So if the acid level is increased, what will you add? You will add any base, for example, which is consumable. Okay, for example, milk of magnesium. Okay, milk of magnesium is the thing which you will use, which will act as an antacid to neutralize the excess acid in your stomach. Okay, then we can also use a mild quantity of baking soda which is there at your home. Okay, you don't have to spend 2 rupees, 3 rupees, 5 rupees or 100 of rupees to just because your acidity level is increased. You don't have to go to medical to get any of this stuff from the shops or medicals. What you have to do is take a glass of water, add a pinch of baking soda and drink it. Okay, what will happen? It will reduce the acidity level in your stomach. Okay, then next thing is do you know why there is something called as an enamel present in your teeth? Okay, in your teeth, this enamel is the strongest present material in your body. Okay, which does not corrode underwater or any other things, but it will corrode under influence of acid. Okay, now how is acid developed or attained, developed in your mouth? तुम्हारा मुंह के अंदर एसिड कैसे बन रहा है? ठीक है, हाउ इज इट हैपनिंग? ठीक है, सो you know, you consume when you consume lot of sugar or any food which is stuck in your mouth, okay, this will be fed, this will be fed by bacteria. Okay, the bacteria which is present in your mouth will feed on this sugars or the food, and this will in return release something called as lactic acid. This lactic acid is enough to corrode your enamel. Okay, once the enamel is corroded, this will lead to something called as tooth decay. Okay, now the pH range of our mouth is 5.7 or 8. Okay, if it is lower than that, if it is lower than 5.5, it will if the pH range is lower than 5.5, it will lead to tooth decay. Okay, so how do you prevent this? Same, need to add base. Okay, either you can wash your mouth properly or else you need to brush it with the toothpaste, because toothpaste consists of a base in it which will neutralize the excess amount of acid released by the bacteria. Okay, then we have certain animals are there, certain insects are there which use acids as their self defense. For example, bee sting. Bee sting consists of nectar. Okay, then let us continue. Okay, so then in pH of the salts. Okay, pH of the salts. Okay, so I have spoken about the types of salt where we have different types, that is neutral salts, acidic salts, and basic salts. These are the types of salt. What is neutral salts? Neutral salts is nothing but a reaction between a strong acid and weak strong base. Okay, a reaction between a strong acid and a strong base will give you something called as neutral salts, where the pH level of these salts are 7. Okay, now acidic salts is nothing but a reaction between a strong acid and a weak base. Okay, and pH here is less than 7. Okay, pH here is less than 7. Then we are going to speak about strong base and weak acid. A reaction between strong base and weak acid will give you something called as basic salts, and here pH is more than 7. Okay, so these are the differences. So we have what? Neutral salts, acidic salts, and basic salts. What do you mean by neutral salts? Neutral salts is nothing but a reaction between strong acid and a strong base. What do you mean by acidic salts? It is nothing but reaction between a strong acid and a weak base. What do you mean by basic salts? It is a reaction between a strong base and a weak acid. Where neutral salts pH level is 7, and for acidic salts pH range is less than 7, and for basic salts it is more than 7. Okay, so hopefully you have understood this. Then we are going to the next part, that is salts. Okay, so first type in that is in types of salt, the first type is a common salt. Okay, that is sodium chloride. Okay, how do we get sodium chloride? It is nothing but a reaction of a strong acid such as HCl and strong base such as NaOH, which will lead in formation of something called as a common salt. Okay, and this is also a neutralization reaction. Here NaCl is a neutral salts. Okay, and this common salts are used in many of our food items, and also in most of the part of the world it is found as an indigenous rock, and this we remove it and we call it as a rock salts. Okay, then coming to next part of this, next type of salt is caustic. Okay, caustic soda. Okay, or NaOH. How do we get NaOH? Okay, it is from NaCl itself. Okay, NaCl, you react it with water, and this we call it as a brine solution. What do we call it as a brine solution? Okay, which in return after passing electricity to it, it gets decomposed to give caustic soda plus chlorine gas plus hydrogen gas. Okay, so what is this? The NaCl and H2O makes an aqueous solution to which we are passing electricity, and later it decomposes to give something called as NaOH and chlorine and hydrogen. NaOH, chlorine and hydrogen. Okay, then here you have to remember. Okay, how do you do this? Okay, there is a container. Okay, there is a container, okay, to which there is a membrane where we are dipping two electrodes. Okay, and it is connected to a battery, that is anode. This side is called as anode, the positive end we call it as anode, and the negative end we call it as a cathode. Okay, so here this we are passing which solution? Brine solution, which is nothing but NaCl plus H2O. Okay, brine solution we are passing through it, this inlet. Okay, and what happens when the electricity is passed through this, electrodes will release two gases. From anode side you will get chlorine, and from cathode side you will get hydrogen. Okay, so these are the two gases which are evolved during this reaction, and the outlet we get something called as NaOH. Okay, here NaOH is used as used for degreasing of metals, and also it is used for detergent, soaps, and other things and all. Okay, whereas a hydrogen gas is used for used as a fuel, and also it can be used for manufacturing of ammonia, which is used for fertilizers. Okay, then we have chlorine gas, which can be used as disinfectant, and also it can be used for production of bleaching powder. Okay, so this reaction it can also be called as a chlor alkali reaction. Okay, chloralkyl reaction. Okay, if they ask you in a question chloralkyl reaction, don't get confused. This is nothing but formation of a caustic soda or a NaOH salt. Okay, so why it is called chlor because chlorine is integrated. Why alkali? Because aqueous solution we call it as alkali. Aqueous basic solution we call it as alkaline, and it's a reaction of that, so that's why it is called as chloralkyl reaction. Okay, so coming to the next part, next type of salt, that is bleaching powder. Okay, now what is bleaching powder? Bleaching powder is nothing but you take a slaked lime. Okay, what do you take? You take a slaked lime, that is nothing but a calcium hydroxide. Okay, and also called as a slaked lime. Okay, the slaked lime on treatment with the chlorine gas will give you something called as calcium oxychloride plus water. Okay, this is also called as water, calcium oxychloride, which is very important for you to remember because it can be asked for exams. Okay, so another name for bleaching powder is calcium oxychloride. And what are the uses of this bleaching powder? तुमने हर वक्त सुना होगा, तुम्हारा घर पे बोले होंगे, अगर तुम्हारा घर के सामने अगर algae formation हुआ है तो your mom might tell go and get a bleaching powder. Why? Because it kills germs and bacteria. Okay, so and it is can be also used as a disinfectant for other things, and also can be used for purification of water by killing germs, and it is mostly used in laundry industries, and it is also used as a strong oxidizing agent in most of the industries. Okay, these are the uses of this. Okay, and if you remember, the chlorine which we have got here is a gas which we got from the our previous reaction. That same chlorine we are going to use here. Okay, then next thing is also very important, that is baking soda. Okay, the baking soda, you know it, we have used it, we most of the times we use it in our kitchens and all to prepare a crispy food and tasty foods. Okay, so baking soda is used for that. Now how do we get this? Okay, nothing, you take NaCl, treat it with the water, carbon dioxide and ammonia. Okay, ammonium. When reacted, you will get ammonium chloride plus the main product, that is metal hydrogen carbonate, or also called as a sodium bicarbonate or hydrogen carbonate. Okay, sodium bicarbonate, hydrogen carbonate, or also called as baking soda. Okay, so when you use this baking soda to your food, obviously if you are doing some pakoras or whatever, you add baking soda to it and you heat it. Okay, you burn it in the flame, or I mean not burn it in the flame, you will cook it on oil. So what is happening? You are generating heat to it. So what happens when baking soda is heated? Okay, when you are heating baking soda, you will get sodium carbonate and water and carbon dioxide. Okay, so this is what is going on. Okay, what is happening when you take sodium hydrogen carbonate, heated it, you will get sodium carbonate, water and carbon dioxide. So carbon dioxide is released. This is the reason whenever you eat any food which is to which baking soda is added, you will feel after eating little bit only, you will feel like your stomach is filled. Because of why? Because carbon dioxide is generated here. Understanding? Then most important question which is asked most of the time, that is what, how do you get baking powder from baking soda? How do you get a baking powder from baking soda? Very simple reaction it is. What you have to do is you have to take an edible acid such as tartric acid. What do you mean by edible acid? Which can be used for foods. Okay, so when you take edible acid and treat it with the baking soda, you will get something called as a baking powder, or also called as sodium salts of acid. Okay, what? Sodium salts of acid. Okay, so it's an that's what we call it as baking powder. Okay, Now, what are the uses of this? One, for most common, we use it for food. Next is we use it as a fire extinguisher, that is called as soda ash. Okay, if I get time, I might show a reaction to you. And it is also used as an antacid. Okay, do you know what is antacid? Because this I have told in pH in our importance of pH in our everyday life. In that I have told about the stomach. Okay, in the stomach we consist of hydrochloric acid. If the level of the acid is increased, how do we neutralize the level of it? Okay, that is by taking antacid. There I had explained about magnesium hydroxide. Here baking soda can also be used as an antacid, which I have told you. Okay, and next is from okay, next thing is a washing soda. Okay, what is it? Washing soda. What is washing soda? It is, how do you get it? Nothing. Okay, you take a sodium carbonate and recrystallize it. You will get something called as washing soda. Okay, so Na2CO3 plus 10H2O. You will get, after recrystallization, you will get Na2CO3 10H2O, also called as sodium carbonate decahydrate. Sodium carbonate decahydrate. Sodium carbonate decahydrate. Okay, so spelling of this is a sodium carbonate decahydrate. What you call this as a sodium carbonate decahydrate. Okay, so this is also there. Okay, now the question arises, this is given as 10H2. Okay, sodium carbonate decahydrates. So this salt, whether it is a wet or dry, okay, this question might be asked. Oh, what am I telling? Whether this given salt is dry or wet. Okay, I call it as a dry. Why? Because whatever this water is there, it is it is in the unit structure of this crystal, unit volume of this crystal, unit structure of this crystal, and this we call it as a water of crystallization. So this is the reason that it is a dry state. Okay, so it is present in the unit structure. Okay, only when you heat it, this water will be released. Okay, but during recrystallization, this water is present in the unit structure as a dry state. Okay, so this is a dry salt. I can give you one more example, that is CuSO4 5H2O. Okay, is blue in color. Okay, when the water is present in the unit structure, it has a water of crystallization. Okay, it is blue in color. Once you heat it, what happens? CuSO4, okay, and 5 times the water pentahydrate is released, giving a confirmation that the color here changed, is the color from blue to, it has changed into colorless white. Okay, and this is why, because the water has been released from it, because the water what was there, it was in a dry state and it was in the unit structure, and that is the reason it was giving implementing a color of blue. Okay, but later after you heated it, the water has been released, making the copper sulfate solute. Copper sulfate has a whitish color. Okay, so further confirming that the water is present in a dry state, and that is it present in the unit crystal of the unit structure of the crystal. Okay, so this will be our answer, water of crystallization. Then next topic is a pop. Okay, what do you mean by pop? Pop is nothing but plaster of Paris. Plaster of Paris. Okay, why do I call it as pop? I'll tell you that it is not the pop which you think, the dancing pop, not the art culture. Okay, so this is a pop, plaster of Paris. How do you get that? Take calcium sulfate decahydrate. Okay, heat it at 373 Kelvin. You will get something called as a plaster of Paris, calcium sulfate hemihydrate. Okay, so, and 1.5 H2. Okay, so calcium sulfate decahydrate, calcium sulfate dihydrate, when treated, when heated at 373 Kelvin, you will get something called as calcium sulfate hemihydrate. The another name for this is a plaster of Paris. And this, whatever is there, I had mentioned this in our pH, importance of pH in everyday life, where I had mentioned about soil. If it is acidic in nature, then we have to add a gypsum. Okay, so this is nothing but a gypsum. Okay, when gypsum is heated at 373 Kelvin, you will get a calcium sulfate hemihydrate, also known as plaster of Paris. Okay, similarly, if you take this, you can reverse it. Okay, if you take this calcium sulfate hemihydrate and treated it with the 1.5 H2O again, you will get gypsum again. Okay, you will get gypsum again. So it's a reactions can be inverted. Okay, so now what are the uses of this? This can be used during if your hand pops out in a sense of fracture. Okay, that's why it call it as pop. So when your hand is popped, you can use pop. Okay, so basically telling when your hand is fractured, you can use a plaster of Paris. Okay, so plaster of Paris can be used for during fracture issues. Okay, then it can be also used to build monuments, and it can also be used in the ceilings to create a design in a new homes. Okay, so these are the uses of this and with this I'm done with the chapter, and hopefully you have understood whatever I have taught. Please revise each and every reactions, and I have also mentioned all the important things which is going to be asked in exams. Okay, and study with uttermost interest. Okay, because जब तक तुम लोग interest नहीं पढ़ोगे, nothing will be done. Hard work is important. Okay, and the luck factor will come only if you are working hard. Okay, and to finish off with this chapter is very easy, and everything is done. I have covered everything. If I have skipped anything, please comment in the YouTube, and we will meet in the next class. Before going, we have two cent. Before going, I would like to tell you that we have two centers in Mangalore. One is in Panambur and one is in PVS. If anyone is interested to come and join, please approach me through Google or comment me in YouTube. And in Google, you will get my number. You can WhatsApp me or you can mail me. And the education institute name is given in the chat box. And in Google, you just have to type Clever Coast Education Mangalore. Okay, you will get my contact number. And I believe every student deserves a chance. Okay, every student deserves to be improved, because most of the schools are not teaching what is necessary. They come, they teach, and they leave the students. Here, we do not do that. Okay, we are trying to change the perspective of every student. Okay, so learn with an interest, and that interest factor will be bought only in Clever Coast. Okay, and we are trying to change an education system. Okay, which is long way to go, but it can only happen with the help of all the students. Okay, and parents, of course. Okay, and we are setting up a new type of tuition classes, that is giving teaching people not just theoretically but also practically. We show them practically what is happening, what is the reason that something has changed its color or everything. So practically we are trying to change the study wise, because most of the colleges they don't do practicals. Okay, so I believe the more you see and learn, the more you see, the more you learn. Okay, so that's the reason we are going to start a practical sessions also. Okay, and I believe every student should take a great decision. Okay, with great decision comes a great opportunity. Okay, so the great decision which you need to take is to join Clever Coast family. Okay, with this I'll end my class. Happy studying, happy learning. Okay, thank you.